So surges are transient events where the AC voltage changes very abruptly, very quickly. And sometimes that can travel through the power supply and get onto the DC rails that are powering our microprocessors. And the microprocessor wants to see a flat DC. They do not want to see any perturbations or any fluctuations in that DC line. And sometimes it's on the DC line, and sometimes it's on the ground. It'll show up there, and the microprocessor will lock up. It just won't work correctly.
So how does the SurgeX technology help reduce those issues in the field?
Well, SurgeX is the only technology that completely eliminates surge. Other surge technologies incorporate MOVs, and that's why they're called surge suppressors, right? The market for a long time was called the surge suppression market, because we only had the technology that took a surge, let's say it was 6,000 volts, and bring it down to a lower level, right? We were suppressing it, we were clamping it down. And you can look at the ratings on surge suppressors and look at their VPR, their voltage protection rating, which is the amount of voltage that gets let through once a 6,000 volt surge is put on its input. But SurgeX technology is not that. We completely eliminate the surge.
So what do you mean it gets let through?
So it, you get 6,000 volts on the input,
right.
6,000 volt peak, spike on the input.
Okay.
How much of that gets let through to the output of the surge protection device?
The connected equipment.
And so it gets presented to the connected equipment. Yeah.
So that's because I think we've, for a long time, called them surge protectors, right, or power protectors.
Yeah.
And that's great. You can kind of get your arms around that.
Yeah.
I've used the strip. I'm protected.
Yeah.
And it's really not. I think it's what a TVSS, right, transient voltage surge suppressor.
Suppressor, yeah. That was the terminology used. And then, UL kind of got into the game and said, there's a lot of snake oil, a lot of misinformation being given out. Right. In the surge suppression or TVSS industry, so they got in the business of rating these things, and they're the people that test surge suppressors. Not all surge suppressors are actually tested by UL. I'm very surprised to see that. Some people will you test under a different UL standard that is not surge suppression standard, and it'll be a device that's in a box that has outlets on it and has a cord, and you'll think, oh, this must be a surge suppression device, but it's really not. It has a different UL designation, trying to give the appearance of being UL certified when it's not. But if it is UL certified under 1449, it'll be given a VPR, a voltage protection rating, which is UL's attempt to arm the consumer with the correct information of how effective is this at doing its job of suppressing the surge. What's kind of funny about that is when SurgeX puts their units in there, UL is forced to give us a VPR rating of 330 volts when the actual let-through voltage is 0,
right.
But they don't have a category for 0, so they have it's like the lowest we can give you is a 330, but the output is 0. Now when I say the output, I mean there's still 120 volt, 60 hertz passing through to the output, but the surge voltage, that transient voltage, is eliminated completely. But it still says 330 on the label. What are you going to do?
And then one thing that we have to remember is these surge suppressors. I like the term surge diverters, because you're really diverting it rather than suppressing it. You're diverting it to ground, and to me that's the worst place you can send this energy. Because these days microprocessor-based systems rely on a good clean ground to make good logic decisions, and blipping that ground at a very high frequency can cause lockups or microprocessor erratic behavior. It's a general term is surge suppressors, but let's face it, they're surge diverters, and they're sending it to the worst possible place. Whereas the SurgeX products, as you know, dissipated internally as heat, which is the right thing to do. Just completely eliminates it, not diverting it, not shunting it, just dissipating it.
On the home side, if I travel to Southern California, Northern California, they'll say, "Oh, SurgeX, we don't have any surges." And I'll say, no, but what you do have is ground contamination. And they don't know, I don't believe, this channel of business that I'm in, the residential channel, doesn't know, because we're still in our infancy stages of trying to understand how power quality affects the system uptime. So this ground contamination, concept, when we explain it, just like you did, Sharon, they get it. But it's not something that is clicking. Instead, what's happened is they just know to go reboot. It's like reactionary, Pavlov's dog.
Yeah.
Customer calls with my TV's down, we reboot the set-top box, TV comes back up again. And we just continue to do that. We've been doing it since before 2010.
Believe me, first thing when I call DirecTV, did you unplug your DirecTV receiver for 19 seconds and plug it back in?
Yeah.
And my first answer is yes, I did.
I'm a power professional. I know to do that.
It's the first thing I tried.